Hello everyone, welcome back to my daily coding series. This is episode 90. I'm going to do a dynamic programming question today. Okay, so this one's called target sum. You are given an array of integers and an integer target. For each number in the array, you can choose to either add or subtract it to a total sum. There are two different ways to sum. Okay, so for instance, 1, 2, we could do +1 and -2. Okay, in this example, there are two ways to get 0, and then we want to return the number of different ways. Alright, so the brute force solution would be to do every combination and see how many add up to target. So just for practice, I'm going to make sure I can do that. So let's call it yeah, so it would be like, so we'd start with nothing, and then we can either take minus the first number. So I don't really know what to call it. I guess like we could do it, think of it like a depth first search, and then it would have definitely the sum and probably I. All right, so I'm thinking at every step, right? Yeah. So we want to basically say total plus equals nums of I. So I guess what we could do first is we could call DFS with I plus 1. And then total would be total plus nums of I. So this is if we added it every time. Zero, 0. Okay, so I want to see, so this should just sum it together. I'm not printing anything. It doesn't return anything. Okay, yeah, so it sums it together, but we need to do so it needs to branch off. And then if we were to do minus, then it would give us -6. Okay, so we need to do like some sort of plus and minus. So in this case, so we'd call plus a bunch of times, but then we would need to, yeah, I guess this would be fine. But we're not returning anything. Let me try this. And then this would give me none. Okay, so the first one is 6, and then it's 2. I guess that would be plus plus minus, and then this 2 would probably be plus minus plus, or to be minus plus plus. So if we trace it, right, so this will call itself plus I goes up to 1, we'll call it again plus I goes up to 2, plus I goes up to 3, it'll print 6. When this returns, it would have been plus plus minus, and then it would get called here. And then after that, so if it's plus plus minus, then it would have been plus minus plus. Okay. So yeah, this looks right. And then how many? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of them. We can just say here, so we definitely want to return no matter what, and I guess I could print it for now, and then we would say if total equals target, then result plus equals 1. Okay, I'm back, sorry about that. So if the total equals target, then result will go up by 1, and then let me print result. So in this case, it says 0. What is target? Target's 4. Yeah, so it's impossible, right? Yeah, it should be impossible to have 4. Okay, so let me try this. Am I printing anything else? I don't think so. Alright, so let's see what happens when I do this. Okay, res is right. So what if we make it so that every DFS call, so it either returns a 1 or a 0. No, I think it's better to just have a counter like this. All right. So let's see if this works. Okay, so this is the brute force approach. All right, so now when it comes to dynamic programming, I'm thinking of what information can we store about every subproblem so that solving the next subproblem is easier. So I guess one way to think about it is if we have 2, 2, 2, one possible way could be like this, and another possible way could be like this. And at both cases, like before we process the third, we're at the same exact position. So we wouldn't really have to, we basically do the same work here twice. When it comes to like bottom up and top down, interesting way to think about it maybe would be, so our target starts at 2. So then from here, now we have like 2 targets maybe. So like, okay, yeah, this is interesting. So after this, we know that if we can get to 0 or 4, so like now we know if this can produce 0 or 4, then that's one combination, if that makes sense. Because we know that we can just add 2 to get 2, or 4 minus 2. So that if we take that a step further, it would be, if this can produce negative 2, 2, 2, or 6, because this one is plus 2 minus 2, sorry, minus 2 plus 2, and this one is minus 2 plus 2. And of course this is just 2. So there's 2 2's. So why is the answer 3? I don't know. I thought this type of thinking would be interesting. Oh, maybe it's because this one could also be minus 2? If you were to do this one more time, you'd have minus 4, 0, 0, 4. No, I don't think that makes sense. So maybe you can just count the number of times, like the absolute value. So here there's 3 absolute values of 2, because this 2 could either be negative 2 or 2. I don't know if this way of thinking actually saves us any time, because, well, maybe it does. Maybe not, though, because we basically have a number, and then we'd have to double it length minus 1 times. Double it and, well, this, wait, maybe this doesn't work. I think it's confusing because it's all 2's. So if we had this, I think now we're saying if this can reach, yeah, so we'd subtract 4 and add 4, and then we would say to all of these, we would subtract 3 and add 3, subtract 3 and add 3. And then here we would see that there are no 2's or negative 2's, so the answer would be 0. But I'm not sure if this saves us any time. So this, let's think about this time complexity. This time complexity is, so if the length is n, then this is, we're doubling every time, like 2 to the n. Because for every call, there's 2 more calls, and we do that n times. For this one, it's yeah, so for this one, it still does look like it has the doubling sort of nature, but maybe it doesn't. So you'd have, yeah, so for everything in the targets array, you have to add and subtract, but it keeps doubling. So it does seem like it's like we do a linear search over something that doubles. I don't know if that's exactly it, but it doesn't seem any more efficient to me. But I do think this type of thinking could get me somewhere. If we approach it from the other side, if we start, so if we look at it from, I think these are both kind of bottom up, but 2 tells us that our totals... so is there a way to do it without calculating every single total? Like, I think shifting the target is a good idea. So maybe the subproblem 3, 4, the problem is there's just many targets. So like now the targets are 0 and 4, right? Because if this can get to 0, then you could just add 2 to it. And if this could get to 4, you could subtract 2. And the order doesn't really matter because it's addition. Yeah, the order does not matter. That's also something to keep in mind. You could process it in any way. I know this problem is also a 2D dynamic programming, so maybe if we thought about it like if we had 2, 3, 4 and 2, 3, 4, and this like plus and minus. So if we did plus the whole time, then it would just be plus 2, so it'd be 2 and then 5 and then 9. And if we did minus the whole time, it'd be, it's going to be tricky with the minus signs. Minus 2, minus 5, minus 9. So what does this point in the matrix represent? Yeah, I kind of like this thinking though. So yeah, I think this is something. So maybe each point in the matrix could be like how many combinations have gotten us to that point, and we can use. So okay. So maybe we have 2. Or if let's say the first answer, the first number is 2. So then we could say -2 and +2. So if I'm thinking about it like maybe we have it so positive, if you go positive it's to the right and negative is down. So then we'd have, so this is our like start and then 2. And then from each of these, yeah, the only thing is, so if we go positive, negative versus negative, positive, that is different. So I don't know if that would make sense because at this point, if you go negative and then positive, you'd have 1. But if you go positive and then negative, you'd have -1. This would be 5. This would be -5. So I'm noticing it is like pretty symmetrical. At this point, if you go negative, negative, positive, let's see that. Negative, negative, positive. Then it would be 1. Right? Because -5 plus 4. If you were to go positive, negative, negative, it would be -5. So positive, negative, negative. It would be -5 plus, no. Positive would be 2. It would be -5. Yeah, so it's not really symmetrical. I do like the idea of like, so if we start with just the base case of 2, so let's say we have 2, 3, 4, and our target is 5. So this should be possible, because if these are positive, you can do this one negative. So with 2, well, I don't know. This first idea was interesting to me. It doesn't seem to cut down the time at all, but so, all right. So now the targets are 1, and so let's have a set. Well, I don't know if you can have a set. Maybe a dictionary. So 1, and that has 1 count, and 9, which has 1 count. So if only we could know maybe this is faster, I don't know. Because it's basically this and then iterating through this. So 3. So we'd pop this and then iterate through this again. And maybe that's faster because so I think what I need to do is analyze how fast that is. Because then you would have 3, and then, okay, so now my targets are -2, which has a count of 1. And then 4, which has a count of 1. And then it would be 6, which has a count of 1. And then 12, which has a count of 1. And then when you get to 2, you basically get you sum up the counts of -2 and +2. And then that gives you 1. So this is an algorithm. The time complexity of it, so what are you doing for every step? For every step, you're scanning through this target. So what is the size of target in terms of n? So n times you'll be scanning through target. And maybe this is just a better way to do it, because any repetition that you have, because it can only grow so much is what I'm thinking. It can only grow up until the sum. So we know that the length of this has to be between, so length of target dict has to be between the negative sum of nums and so let's say it's greater than or equal to the negative sum of nums, and that is if you were to take the sum of this and then times it by -1. Well, actually, now that I think about it, you can't have a negative length. So in other words, so the minimum value would be that, and the positive value would be the sum of the numbers. So that means the length has to be less than or equal to 2 times the sum of the numbers. So if each number can be 1,000, yeah, this seems pretty good then, because each number can be 1,000, up to 1,000, so from 0 to 1,000, and there can be 20. There can be 20. So that means there would be, you could sum up to 20,000. So 2 times 20,000 would be 40,000. So it would be n times 40,000. And n is the number length. So it would be 20 times 40,000, which would be 800,000, right? Because multiply this by 2, 80,000, then add a 0. So that's totally doable in the worst case. So I think I'll implement this. It's strange to use the sum. Yeah, I don't... there's definitely a better way to do it, I know for sure, because I don't think relying on the sum being low is like a good metric. Let's see what the recommended. So this is n times m, where n... Oh my gosh, really? N is the size, and m is the sum of all the elements. Interesting. So n is the size, and m is the sum of all the elements. And well, I said 2, but you can kind of get rid of that. Okay, so I think I have the right idea then. All right. So the only tricky thing, so let me write out a little pseudo algorithm for it. The only tricky thing would be updating the dictionary as you go through it. So I could just make a copy of it. I don't think I would need pseudocode for this. Let me just look at so the constraints are pretty fair. All right. So I'm going to call it target dict, and then we're going to have our nums. So do I have to do it backwards? I don't think I have to do it backwards. I don't think I have to do it backwards because... So I did it backwards. Let me see what happens when I do it forwards. That is to end with 4. So our target is 5. So we would take out the 2 first, and then our targets would be... just keep it consistent. Then our targets would be 3 and 7. Then for 4, well, we would take out 3. I guess you don't really have to take it out per se, but that would be 4, and then our targets would be negative 1, 1, and then it would be 7, 2. So if we add 4, and then 7 minus 4 would be 3, 1. And plus 4 would be 11, 1. Is this giving me the same numbers? It looks like it's giving me different numbers. And then... Did I do something wrong? Because here there's no 4s. Do you have to do it the other way? I don't see why you would have to. Yeah, so it'd be... Yep, 3, 7, and then 3... Oh, it'd be 0, right? If you subtract 3... Sorry, I think I got a little lost for a second. So if you subtract 3, you'd get 0. If you add 3, you'd get 6. And then you keep the original 3. And then for 7, if you if you subtract 3, you'd get 4. And if you add 3, you'd get 10. And then this has 1 4 in it. I wonder if I messed up the arithmetic in this example. Or if it actually gives you different numbers. I don't think it should. Well, I guess, yeah, I guess it does. I guess it would. It would, because I don't think it matters which way you do it, but if you start obviously with 2, then you're going to get 3 and 7, and if you start with 4, then you're going to get 1 and 9. So I'll just start from the beginning. So we'll have and then I guess I'll just do a copy of the dictionary. I'll just sort that out. So we have a target dictionary which has nothing in it. We are going to say for I don't know if we need I. Let's just say for num in nums. What do we want to do? We want to well, I guess we need to have something in here. So maybe we can start from the second num. From 1 until length of nums. Whoops. And this will be nums of 0, 1, and negative nums. Let me see the restraints. So we have to have at least one num. Okay. So that looks good. So before I continue, so with the edge case, if I had just one number, let's say 5, then my target dictionary would be, well, I suppose it would be relative to the target. So it's not just 5 and negative 5. It would be target minus nums and target plus nums. So if the target, let's say, was 6, then it would be, okay, our new targets are 1, is it 1? Is it 6 minus 5, or is it 5 minus 6? If our target is 6, then this is telling us what we would need. So if we had a 1, I think it's actually this minus target. And this plus target, which the order doesn't matter, but just keep it consistent. And the reason is, so if we had 5, then it would now generate negative 1, which makes sense because then we could add 6 to it. If we reached a negative 1 by the time we got 5, no, I don't think that's it. Because this is like, all right, let me go back to the drawing board here. So when we have something like this, and we remove the 2, or let's just say we have I. So at this point, we're saying this whole thing needs to have a target of 5. When we go here, now we're saying this whole thing needs to have a target of, like, if this was able to reach 7, or 3, then we'd be good, because we can add 2 to it. Like, so if this reaches 7, then we know we can hit our initial target of 5 by just subtracting 2. So how did I get 7 and 3? I did target minus, okay, yeah, so what I did have it right the first time. It's target minus the number. All right, so if we have 1, we would do target minus 6. So that would be 1. And we would have 11. And now that is neither, so 5, this would return 0, which it makes sense because 5 cannot reach 6. If it was 5, then we would get target minus nums which is 0, and then we'd get 10. And based on the way we're checking it, well, we check it based on the last number, actually. So we don't evaluate the last number. So, all right. So before I optimize for the edge case, or I guess think about the edge case, if I consider how we were doing the general case, when we got to the last number, when we got to the last number, that's when we did the comparison. So we'd have to do the comparison at this stage. So my question is, do we add the target to the dictionary? So we definitely don't do this. Do we add the target to the dictionary immediately? And I don't think so. I don't think so. We add 7 and 3. What if we also had 2 in here? Would that make any sense? So that means or did I have it right initially? How you start off with, so when I is here, do you just start off with 2 and -2? Because that's what you can reach at that point. And then with 3, would you just do it? I guess that kind of would make some sense. Because we know if I is at this point, if this the whole subproblem can equal 2 or -2, then we're no. What does this mean? This means that the subproblem has to equal this. But we want it to equal 5, right? We want it to equal the target. It has to be the target. When we come here, now we're saying we can delete this. Oh, I think I have to delete the old entries, because the old entries are no longer valid. So in this case now, we're saying from our initial target 5, we've just processed 2. So that means we can have either 3 or 7. And then once we go here, we'd have to, would we delete it? I don't know if I'm confusing myself, because I feel like I was so sure about that. But I guess it makes sense, because if you reached this point with a 3 or 7, then it doesn't really help you at all. So then here would be okay, so I'm thinking we can use a default dictionary and then set all of the counts to 0, and then whenever we process a number, we would first subtract it. So we'd subtract like the target's count by 1 and then add its plus and minus nums of I. So my idea would be, so this would actually start with target. And then at the end, we're checking, we want to return the sum of target dict of the last number plus target dict of the negative last number. So if our last number is 4, We want to see how many times does 4 come up and if it's negative 4. And if it's not there, it will just do 0 because this will be a default dict of integer. Yeah, okay, so now I'm thinking, so for instance, if we just had nums as 5, so let's say nums is 5. Let me print this. And we don't need sum, we can just use the... So target dict is a default dictionary, and it says 4 is 1. But I wanted to change nums to be 5. I guess I can do that. Alright. Well, if we just trace the code, it's not too complicated. So if we have just nums as 5, this will get skipped. So then it will say, and let's say the target is also 5. It will say target dict of 5 equals 1. And then it will say target dict of 5 plus target dict of negative 5, which will be 1 plus 0, and it will return 1. If the target was 6, then these would both be 0 because, yeah, they would both be 0 because 5 wouldn't be in the dictionary. Only 6 would be. Alright, so now what we're going to do is at every step, we want to iterate through the dictionary. So we would say for I guess I could just say for t in target dict. Let's make it target dict dot keys. So this returns a list. So this will give us a list of all of the targets. What we're going to do is first say target dict of t minus equals 1, but target dict of t plus nums of I plus equals 1, and target dict of, I think, t minus nums of I plus equals 1. So we're going to remove the original. So in this case, if we look here, so I starts here, and our target dictionary is just 5 at this stage. So when I is here, for t and target dict dot keys. So now that'll just be 5, and it's 5 1. So it'll do 5, and it will say, okay, so 5 is going to go down to 0. That's what this does. Now t plus nums of I. So what is t? T is 5. So t plus nums of I would be 5 plus 3. So now it's say 8. Yeah, but we want to do it with 2, right? Yeah, so if I is at 1. So maybe we just start I at 0? Or do we just say I minus 1? I think we are interested in doing this. just for, I mean, maybe this is stupid, but in the one case, if we have just a length of 1, then this would trigger if we started at 0, and then that would change the target. Yeah, I think I need to think more closely about my start and stop condition. So now with the code how I have it, so once it does the changes to 4, it'll go out here, do the changes again. I think maybe we stop here, and then on the last one it doesn't process. I think that's how I want it. Yeah, I think that's how I want it. Alright. Okay, so let's assume that this works. Then when we get to the end... Alright, so let's see what this does. I think that's like all the parts of it. Yeah, okay, I was worried about this happening. So, alright, so let me print target dict after every step, and what it's also initialized to. Okay, so it starts as 4, and then after we... Alright, so why is it not going down? Yeah, that's the issue. So 4... Oh, well, it does go to 0. Alright, so it's 4, 6, 2, 8, or 0. And then it's saying, okay, 2 is in there. Oh, is it because it's processing this? Because at this stage, 2 should not be in there, but it... Okay. So I think I should delete it. If... So that would delete it. Yeah, so that fixes that. And then how does this look? So yeah, that looks perfect. Okay, so let me get rid of the print statements. I'll try submitting it. Let's get rid of this stuff. Maybe that's why it was working. No, that's unreachable. Alright, so let's use this as a test case. Let's see what's happening. So it starts with 3, and then we go 4, 2, and then we go 5, 3, 1. And we go 3, 3, 6, 4, 2. Alright, and the last one is 1, right? So it should sum together 1 and -1. But the answer is really 5. The answer is 5. Okay, so at this point with the whole thing, it's only if it creates 3. That's... Is it fair to say 1? Or are we solving for this number? Yeah, maybe this is not fair because I'm saying that there's only one way to reach the target, right? Is that what I'm saying? Yeah, maybe this whole thing assumes, because when I say, so if I'm using the counts, but I say if I start it with 1, yeah, you can't really decide. Yeah, if you're going to use the target, you can't really decide for it how many. So I wonder if what this code is doing is like assuming that there's only one way to get there. No, it doesn't make any sense. Because the way I read it is like, okay, if you have a 4 with a 2, it means that if you were to reach 4, then you would have 2 ways to do it. So if you apply that same logic and say, if you were to reach 3, you'd have 1 way to do it. I feel like that's not like a fair assumption to make. Alright, I'm going to look at the solution for this one, and I'll come back. Okay, I'm back. So after looking at the solution, I realized I was kind of on the right track. There's just a couple things that I was missing. So for instance, you can't assume that the target has one way to get there like I was doing. You want to assume that 0 has one way to get there, and then you go based on that. Also, instead of just adding 1, you need to add the count of how many times you've gotten there. So maybe I could say something like, yeah, the items. So you can see here they iterate over the items and then use the value of the dictionary itself. So they basically did like a manual copy. I'm just going to do it this way. I think it's fine. So we add counts. And actually, I think doing this is unnecessary. This would be unnecessary because we would be adding 0, but I still think it would be fine. They never like subtract 1. I don't know why. And then also the return value, instead of returning this, you just return the dictionary of the target. So that's the only time you really use the target is at the end. And this is for the bottom. I think it was bottom up, right? Yeah, bottom up. Right. I am also starting at 1, which I don't think I have to do because you want to start with because you're starting now that 0 goes to 1, like there's a 1 way to go to 0. You need to process the first number, and then instead of I minus 1, I can just use I. Okay, so let me see where that gets me. Okay, so that seemed to work for the first 2, which is good. Okay, so I have a very big output, and they have a very small output. Let me see what my dictionary looks like. Forgot to use that as a test case. Okay. Okay. So do I start? Is it because of this code? No. So you need that code. Okay, so let me look at differences in the code. So this doesn't exist in the... So maybe instead of -1, do I have to just bring it to 0? Or do I just delete it? Maybe I just delete it. Yeah, So I think it's just much cleaner probably to just make a new dictionary. Because this one, I'm deleting it. The reason I did that is because I just saw that, well, you're bringing it down by 1. So then the count would probably like carry over when you increment it here. But you want to delete it altogether, but maybe you want to subtract it by the count. Maybe I'm supposed to subtract it by the count. Okay. Right. Okay. So I think I had the right idea. I just made... Okay, so what would I need to do differently next time to get the solution myself? I would have to recognize that the valid assumption that you make is this right here. And this is saying that there is only one way to get to 0 before you start. Like when you have an empty... I think that's what it means, like if you were to translate it to English. I mean, it makes the math work out, but if you have just an empty list, then you can only get to 0. Yeah, okay. Yes, so the key is like the sum, and the value is how many ways you can get there. And that's exactly why we return the target key, because this returns how many ways can we get to the target, which is the problem. So this says before we do anything, before we iterate at all, the only thing that we know is that we can get to nothing, and there's only one way to get there. So that's the assumption that you have to make. Also, as well as defining exactly what... I think I was a little loose in my understanding of defining what the dictionary represented at all. So I think realizing that we can map at every step, we can map a number and how many ways there are to get there. And then eventually realizing that's the whole problem. So we can, at the end when we're done, just return that for the target. So anyway, thanks for watching. I think that was episode 90, and I'll see you guys next time.